Okay, so we're going to talk about files and how you can write to files, read to files, fun things like that. A lot of this is really just based on what Java does behind the scenes, so it's fairly simple to deal with. First thing we're going to look at is creating something called a abstract file name, and that looks like this. And we're going to use java.io.file and pass in a file name. Let's call a little text file here. And this creates a file name. It doesn't actually represent a file on the disk. It's actually just a name, a placeholder, path, things like that. This particular one is going to create something in the current working directory, so wherever the application is run from. And what we're going to do is we're going to use a really simple function here called write text. And why is that not working? It's not giving me anything here. I need a function. That's exactly what I do. Thank you. When I created this thing, I accidentally created class instead of files. Thank you. I was totally looking in the wrong spot there. Now we should be in good shape. Write text. So write text is an extension function on file. If we take a look at his definition, he actually is file.writeText. So Kotlin is extending the behavior of this Java class. And then we can pass in whatever we want to write. So you could pass in just a single string like Scott. And if we run this, we're going to see that, where did it create it? Should have created it in that directory. Shouldn't be in these. Why am I not seeing where that one went? Where's a reload from disk? There he is. Okay. It just wasn't synced up there. So hello.txt just has that Scott in it, and we're all great safe there. So now we can also use raw strings. So I can say file.writeText, line 1, 2, 3, and 4, something kind of like that. And now if I run it, when I take a look at hello, notice how Scott is gone. I completely overwrote the file content by saying write text. Now we can instead say append text, and then we run that. Now when we take a look, we'll see that Scott was there. Note that when I wrote that, there was no new line after Scott, so it just printed out Scott, and then the rest of the lines were written right after him. And this is good for short pieces of text. I'll say short-ish text. Write text is a decent choice. And the thing that's nice about this is you can just set up this write string. Inside the write string, you can have expressions that call other functions and things like that to set up something for a file. So it's fairly nice there for setting him up. But if you want something more flexible, you're going to want to take control for yourself of how the writing is actually happening. Keep in mind what this is doing is this write text call is going to be opening the file, writing the content, closing the file, and handling any type of exceptions that may happen during that write so that you get an atomic operation out of it. So your append text here is going to take that single string, write it out, handle errors, things like that. Now, if we wanted to read that back in, I can do the opposite. I can say val text equals file.readText. And if I don't specify a character encoding here, it's going to default to, I believe, UTF-8. Yeah, it defaults to UTF-8 as the character encoding. Otherwise, you can specify a specific character encoding like UTF-16 if you wanted to, or if you're on a specific platform and want to use that specific platform's common encoding, you could use that as well. So using this, I'm going to say println text, and now when I run this thing, we'll see that it printed out that content from the file just fine there. And once again, this is useful for small-ish type input. Okay. Now, if we want to do a lot of data where we're working in chunks, that's when we really want to start thinking about managing the data ourselves. And I want to do types of file writes and reads. So we have binary files and we have text files. And the way that those are represented in Java, if it's binary, we're using some classes called input stream. Whoops. And surprisingly enough, output stream. If it's text, we're going to use things called reader and writer. So whenever you see things about that have reader in their name or writer in their name, it's assuming that it's going to be writing text using whatever encoding is set up at the file level. Now we're going to talk a little bit later about using the decorator and adapter patterns to modify the output to these guys so that we could actually create a custom wrapper that whenever you write to it, it does something automatically for you. Kind of like I like to think of it as coffee filters, where the actual file that you're writing to is the coffee pot, and the coffee filter kind of tweaks the stuff being put into it to change its behavior or change its nature. So let's start looking at some details here. These examples are evil, and the reason they're evil is because they don't properly deal with error handling. One of the things you can get into trouble with is if you don't close your files. Files can be left open on the file system, and eventually you can run out of available file handlers while your program's running. So you want to be really, really careful to make sure that your file is closed. All of these calls we saw up here, those are definitely closing the file. So regardless of what type of error might have happened, we're going to close the file. These ones, file might not get closed. Let's take a look at just a really direct way of writing out some stuff here. So I'm going to say val file1 equals file1 dot text, and I'm going to say val fw1 equals file writer file1. And what this does is this creates a writer object. Note that I'm using the word writer, so we're talking about text is going to be written to this, wrapping around that file. So we're going to use that file name for this writing to a file. Let's go ahead and do some things like 1.100 for each fw1.write it to string. So we're going to take that integer that's passed in, convert it to a string to write out, and then fw1.write new line, something kind of like that. And then we'll do an fw1.close. And here's where the problem is. If an exception occurred while writing the file, this would not get called. So that's something that we want to be really careful about here. We want to make sure that we're always going to close our files. But for what we're doing here, we're probably not going to have an error. Just keep in mind if you're running on a server or something, there may be a billion things happening. It's very possible that you get an error. Maybe a disk got corrupted or something like that. Let's go ahead and run this. And we'll take a look and see if that, refresh it probably. So we're going to reload from disk. And there he is. There's our numbers, 1 through 100. Ta-da! So far, so good. So let's, if we take a look at this here, that looks a little awkward. What we're doing is we're writing strings, we're writing numbers, things like that. Well, actually just writing strings here. It'd be nice if we could take advantage of that whole println functionality, so it'll automatically do a new line after things. So, and also automatically handle printing out. It'll take care of the toString for you. So let's make a copy of this guy. And I'm going to change these to file2 to there. There we go. We'll make this be file2. And what I'm going to do is I'm going to wrap this in a print writer. Now, print writer has a slightly different interface. So what we're creating here is something called an adapter. I'm going to call this PW2 is a print writer wrapped around file writer 2. And what this does for us is print writer has a slightly different interface. So we're adapting what the file writer looks like so we can make different calls to it. We'll make calls on print writer. It's going to do whatever the adapting is, then call the appropriate write functions under the covers for that file writer. So now I can change this to, instead of being that guy, I can say println it, just like that. That's a little bit nicer. So we're nesting these writers on top of each other. The one that I'm talking to is the print writer. He makes some modifications, calls the file writer. He makes some modifications, writes the data out to the disk. So now if I look at that, I should basically see the same thing. Let's get our file2, and we see our numbers 1 through 100. Perfect. So exactly what we're expecting. Questions so far? Okay, so now let's do a binary file. Take the same structure. Oops. And we're going to change this a little bit. I'm going to say file3.bin. I'm going to write a binary file. The file name itself doesn't matter. It's just what we do with it. And in this one, I'm going to do a file output stream for him. And let's rename that actually. Instead of doing a println, we're going to try to write out the data as binary data. So I'm going to say write. And let's go ahead and run that. And we'll get our binary file and see if that looks interesting. Whoops, come here. Reload from disk. And what do I want? I guess I'll just try opening it in text. It's going to look gross, but we can see there's binary stuff in there that we're trying to interpret as text, which is inappropriate. So I'm going to remove that association because I don't want to keep saying binary files are going to be read that way. So that's writing a simple binary file there. And what we can do is read that back in an integer at a time. And we're not going to need to rename that. Let's rename this one to file input stream and make that be a file input stream. And this time I'm going to read an integer out of there. And because we're just walking through this, we don't care what the value is. We're not actually printing it out. So I'm going to use an underscore to say I'm ignoring that parameter. All I'm doing is walking 100 times. Now, another way we could do the same thing is if we said repeat 100 times. Kind of like that. It's another function. But once again, he has a parameter coming in there. Sometimes that's a nicer way to write things. So we're going to read this guy, and let's go ahead and println. What this is doing is we're now writing out 100 integers to this binary file, and then we're going to read 100 integers out of the file and print them out. And let's try that, see if it actually prints out 100 integers. There we go. worked just fine. Okay, any questions so far? Okay, well, we're going to fix the evil in the next file. So let's take a look at this guy, and I'm going to remember to actually change it to a function so I don't get confused by that yet again. And let's see what we're going to do here. I've already talked about the adapter and decorator patterns, so I'm not going to go through. I had an example here where I was explicitly writing adapters and decorators. We'll see something like that when I do the one for the files. So we'll come back to that later. So what I want to do here is I want to deal with the exceptions that could be handled. And so what I'm going to do is I'm going to create a function that represents writing something out, passing in a lambda for the actual what gets written, and then having the control structure that deals with the exception handling inside the function. So if I come into here, let's start this off by saying I want to do it on a writer class. So I'm going to extend writer. And let's call it IO stuff. I'm going to have a block that I'm passing in that takes a writer and does something, doesn't return any value. So that's my basic contract with the outside world. I'm going to take a writer called IO stuff and have some curly braces after it in order to call it and do things. So that'll look kind of like if I start off with a val file1 equals file1.text. And then I can do a val file writer1 equals file writer wrapped around file1. And then I can do something like, I was just looking at my example. I had something else in there. I'm like, what am I doing? I can say fw1.io stuff, curly brace, and then inside here I get passed a writer. I can write stuff to it. So I could do things like actually let's do 100 to 200 for each. And then inside here I could say writer. Well, let's go ahead and name that explicitly. Writer.write. Whoops. Oh, silly me. This is where I wanted to have writer. Let's put it in the right spot, huh? It to string. And then we'll do the same kind of thing we did before. Now this looks really similar to what we did before, but notice how I don't have that close anywhere in here. I'm going to put the close inside IO stuff. So IO stuff is going to be responsible for properly closing this thing off no matter what happens error-wise. So this is kind of how it gets called. Let's see what we're going to do to actually make that actually work. So to start with, I'm going to have a try block here to deal with some exceptions. I'm going to call that block inside the try block. And now, well, I need to pass in the writer. And now I can actually catch exceptions and do things with them. So I can say catch some kind of exception that comes in here. And I'm just going to use throwable. So I'm going to catch any type of problem at all. And then I want to make sure I close it. Now, the thing that's going to be tricky is I can't just say close in here. Well, I could. I could say writer, no, actually just close. But then I also have to have it in here, right? So if everything goes fine, I close it. If there's an error, I close it. And that could work. But there's a couple little problems here. First of all, the duplication. I really don't like duplication a lot. So I would prefer, if you're going to do the same type of thing everywhere, to have a finally block that's going to do that close for me. So that no matter how things ended up, if I succeeded or if I had a catch, I'm always going to try to close. And so this is pretty good so far. But what happens if the close fails? So if we're trying to close this file and that fails, let's suppose something went wrong when that block was running. Maybe we got some kind of an IO exception. If the close fails, the resulting exception out of this whole function is going to be the exception for the close. Because Java and Kotlin only keep track of the last exception that was thrown during the processing. So in this particular case, close fails, boom, we're out. I would much rather be notified about the error when I was writing. That an error on a close failure isn't really that interesting unless there wasn't any other error. But if we had an error while we're trying to write and we had an error during the close, it'd be much better to report the previous error. So what I want to do is I want to make sure that when we have an exception thrown, I hold on to it just in case the close fails. And that way I can just report the exception I really care about. So to do that, I'm going to create a var pending exception. And this is going to be a nullable throwable that starts off as null. And then inside here, I'm going to say pending exception equals E. Then when I close down here, I can do another try around him. And then I can say catch E throwable. And then inside there, I can say throw pending exception Elvis E, just like that. And so I'm using Elvis here to say if I have a pending exception that was caught up here, throw it. Otherwise, throw the exception that happened inside of the close there. Okay. Now, the other thing I need to do inside this, though, is if I had a pending exception and I didn't fail on the close, I still want to actually throw it. So that's where I can use another finally here and say throw pending exception. And what's he unhappy about there? Oh. Because he's nullable. There we go. Something kind of like that. Okay, does that make some sense? So this is a really safe way to handle things. Now, Kotlin's smart, so they did something like this already. They implemented a very similar function to this. I haven't looked at it in a while, so I don't know if they're doing it quite as thoroughly as I am. I hope so. They implemented a function called use. And so it's very, very similar here. Let's make a copy of that. Make that be file 2, and I can just say boop, .use. So the way you use it looks exactly the same. Let's take a quick look at what use is doing. Oh yeah, it's basically the same thing I just wrote. Very, very close. They're using a when block at the end here, and API version. That's interesting. Oh, so they have a function here that takes care of the close at the end here. Oh, interesting. So what they're doing here, they're actually taking advantage of the suppressed stuff. So on an exception, you can actually have suppressed exceptions attached to it. Because what will happen with Java or Kotlin is, remember, the latest exception will get reported. What they're doing here is they're making sure that I'm reporting the one exception, but I'm attaching other exceptions that are associated with it. That's nice. I like this approach a little better than, and you're not going to hear me say this often, I like this approach better than what I did. Now, I had done this whole block approach here in Java quite a while back, and I used a template method for it before Java had try with resources, which takes care of a lot of this for us. The use block is very similar to try with resources in Java, but this is what I recommended doing before that happened. Now it's like we have this wonderful use, which from what I can see there, they did a really nice job implementing. I'm very impressed. The Java try with resources wasn't quite as nice, but it's close. So this is really just showing you kind of like what happens behind the scenes if you really want to do this right. Okay, any questions on that? Okay, let's take a look at another guy here. Let's say I want to take that file and I want to read all the lines from it. So I already have file 2. Let's call this one, let's just use a file writer directly. So I'm going to come here and say file reader wrapped around file 2. And instead of use, I'm going to say use lines. And what this does for me is, he's going to actually return one line at a time from the file, and you can do something with it. So inside here, I might do something kind of like a lines dot. The lines coming in here is a list of strings. So maybe I can say filter. Oh, sorry. There we go. Filter it.length is greater than 2. So I'll only deal with lines that are greater than 2. And then I can add in a for each. And inside there, say println it. And this should ignore all the single digit numbers inside that file. Well, I don't have any single digits because I'm doing 100 to 200. Let's change that back. This is file.2. Let's call it file 2a. Let's go ahead and run that. Boom. Now if we scroll up, we shouldn't see any single digit numbers now, unless we see single digit numbers. So what do we get here? Filter length is greater than 2. Well, that's not right. Why does anything get printed out? I'm running the wrong file. Okay, let's run the right file here. There we go. So what that was doing is anytime it only prints the line where it's greater than 2. Let's make it greater than 1, so it should print everything except for the single digits. There we go. Perfect. So this way, if it's reading the entire file in, giving this array to work with. Once again, if it's a really, really big file, this is not a good idea. But if it's not a huge file, then this will work really well. Okay, questions on that? Why did I have a lot of gobbledygook written in this other file. I'm going to show you what it was just because it's kind of interesting. I'm not sure what brought it up. Just going to copy these guys over. So in the olden days, like back when I used to work at IBM in the 90s on a mainframe computer, thankfully without punch cards, we actually had a screen that let us type in 80 characters and it was all green. It was gross. But way back in the olden days, exceptions weren't a thing. So we had to do everything with what we call result codes. So all of our functions that we wrote would have some kind of return value coming back. And generally, if it returned 0, that meant everything was fine. If it was non-zero, it meant something went wrong. And you'd have different, kind of conventions for what return codes meant. What you'd have to do is you have to check, did everything go okay every single time? And when I first started there, the way that people were writing stuff looked kind of like this, where you'd say, call the first one. If his result called to 0, call the second one, so on and so on. And the big problem here with 80 columns is you very quickly ran out of space. So I took to a different convention and I got completely screamed at during my first code review doing this. I said, call it, check the return code, call the next one, check the return code, call the next one, call it, so on and so on. And they were screaming at me in this code review saying, that's wrong, you can't do it that way. And I'm like, Okay, first of all, we're doing the exact same number of comparisons, so there's no harm there. But take a look at the space I have in my file here. It reads much more like a straight flow of things to do. And then at the end, you just say, hey, what was the result of all this? If there's an error, we don't do anything else. We end up comparing more times, but in an error situation, does that really hurt so much? It's not like you're really hurting your main run. So you'd have some other things there. They kind of grumbled about it a little bit, but eventually we got exceptions, and exceptions are much closer to this kind of flow. And I ended up loving exceptions. I thought that was fantastic. So something kind of like that, using exceptions, would look more like, oh, did I paste that in there? Oh, that's the IO stuff. So using exceptions for this might look something more like this, where we say, here's my do A, but I have an exception. So inside of here, if there's a problem, I'm throwing an exception. If there's a problem, I throw an exception. So no return codes necessary. I didn't have to check anything. And the calls for this would just look like this, which feels to me very similar to using those return codes like I was using, except now I don't have the ifs in there, which is fantastic. And the exceptions capture other information, such as your stack trace. So you can really debug things a lot easier. So exceptions were a big win. Now you can also put those inside of try-catch blocks so that, like in this particular case, I'm going to do this, maybe report an error, but keep going by using a try. When I catch the exception, it no longer gets thrown outside of the function, and so on and so on. So something kind of like that. Now, a big note here. In Kotlin, exceptions are not checked. I should actually say there are no checked exceptions. That reads a little bit better. In Java, some exceptions are checked exceptions. For Java, that happens for anything that is not under runtime exception in the hierarchy. So you have a hierarchy that looks kind of like throwable, and underneath there, it has error and exception, and underneath exception is runtime exception. So you have a hierarchy that looks kind of like that. Anything that's not under runtime exception is considered a checked exception in Java. And with a checked exception in Java, the contract is either you must catch the exception or declare it's thrown by the function. And I hated this. I hated this with a passion. The big problem with it is that as you're creating these call chains, A calls B, calls C, calls D, and so on, way down in the bowels of this thing, you realize, oh, D needs to throw an exception. And it's a checked exception, like an IO exception or something like that. Therefore, I either need to handle it in D, which probably doesn't make sense. You really want to just kind of propagate that up to a spot that really can deal with it. Or you have to declare it's thrown. So you either handle it or you declare it's thrown. So then you end up having to change everything in the call chain going up to throw these exceptions or catch them. It's a real nightmare. I like to have kind of higher level exception handlers because a lot of errors you really can't do anything with at a low level. Think about an IO exception. You could try again, but once you try again, if it fails again, there's really nothing you can do about it. You just have to report it to the user. So you let that propagate up your call chain to a higher level function, as opposed to a higher order function. Don't get those two confused. But some function up at a higher level, and let that report to the user what the error was. I really hated that. In Kotlin, you don't have checked exceptions. That is really awesome. So that means there's no throws clause on functions. Everything is just treated like if you throw it, boom, it propagates up the stack until you catch it somewhere. Now, the downside of that, of course, is that you don't get extra information in your IDE to let you know, hey, this function might throw some exceptions. So you lose a little bit there, but I don't think it's a big loss, because that Java really enforced that whole every place up the call chain had to throws. It was just a pain in the butt. You really had to end up going and changing a whole call stack quite often. Okay, any questions on that? Okay, let's do something a little cool to capture an interesting behavior that we want to affect an entire reader. What I'd like to do is, let me first of all change this before I forget. What I'd like to do here is set up a wrapper around a file writer that automatically uppercases everything. And to do that, I'm going to create a decorator for it. So I'm going to have the same interface, same type of functions being called, but I'm going to wrap it around the real object that I'm dealing with. So I'm going to use something called a filter writer, which does a lot of the work for me, and just override some functions to do the uppercasing. So let's do this. Let's say class uppercase writer. And this guy is going to have a real writer being passed in. And that's going to be a writer. And take a look at my example. And for some reason, I had the writer be nullable. Why on earth would I want that? I really don't. I want the writer to be non-null passing in. I don't think it makes any sense to wrap an uppercase writer around a null writer inside. Let me check what filter writer. Well, we'll come back to it. What we're going to do is we're going to take filter writer, and we're going to pass in that real writer. So filter writer is a real simple decorator. If we take a look at him, ooh, it's just going to be binary. It's like, nope, let's not do that. Unfortunately, I don't have the source in there. But what he does is he takes that writer and he delegates all the functions to it. We can then override whichever functions inside writer that we want and change the behavior. So to do those, I'm going to override the write function that takes a single integer, which represents a single character, and I'm going to modify that. So I'm going to say super write c dot to a character. So we're going to convert that integer code that it's reading from the file into a character based on the encoding that's being used there. I'm going to convert it to be an uppercase character, and then I'm going to convert it back into that integer to come back over there. So poof, what this is doing is it takes that integer code for the character, converts it to a character, calls the uppercase on it for the current character set, and converts it back to an integer, and then just calls the superclass version of it. Now the superclass version of that inside the filter writer is just going to delegate it to the real writer. Boom. So that's going to upgrade a single character for us. There's a couple other writes that we need to override. One that takes a string, and he's going to be a little bit easier. We just say string.uppercase. Boom. So he's going to convert the whole string to uppercase, call the superclass one. Boom. We have uppercase written out. There's another one here, right? Taking a character array. And this one, is there an uppercase on him? I can't remember. I know what I did here. So I'm going to call toString on him. And instead of calling superWrite, I'm just going to call write. So this one is going to call this function where we do the uppercase. Nice and simple. And then we have another guy that's going to take a string with some sizes. So what I'm going to do is I'm just going to say string.uppercase, passing in those the offset and the length that I want to take that substring, call the superclass with it. Now this one isn't as efficient because what I could also do is just, before I did the uppercase, I could do the offset and length myself to pull that substring and then uppercase it, passing it to this guy. That's another option. This one's a little bit less efficient because if this range is a very small part of the overall string, I'm still going to uppercase the whole string. I'm just going to leave it like this, though, for now. And then we got one more, which takes a character buff to do that. And this one was a little bit more complex. The way that I did this is I said val new buff equals char array with the length. So I'm creating a new buffer with just that number of characters. And then I'm going to say cbuff, oops, come on, dot copy into the new buffer and pass in the location I want to copy to in the new buffer. So that's position 0. The offset inside the cbuff that I'm copying from. And then the ending offset plus length. And no, copy into, not copy of. And that will copy into the new buffer at destination 0, starting at the offset inside cbuff for up till that end index. Okay. Once we have that, I want to uppercase all the pieces. Now I could uppercase everything, or I'll do it with the explicit thing here just so you kind of see what it looks like. So new buff dot indices. The other thing I could do is convert the new buff just like I did here. Convert it to a string and write it, and then we're done. But another way is to be explicit about this and convert each character independently. So it might look something kind of like this. And then we'll say new buff sub it, so whatever that character is here. I'm going to actually just change that to n instead of it. We'll just use a little character there. Equals new buff sub n dot uppercase character. So we'll replace that. Finally, we call superWrite, passing in the new buff without the offset and the length. There we go. I just noticed in my existing code that I had, I actually passed in the offset and length, which that would be bad here because it would totally not work right. So those are the ones that we have to overwrite for this to work. There are a bunch of other functions in Writer that filter writer overrides, but we don't need to change them. We're only changing how things get written here. So now what I'm going to do is go into my main, and I'm going to say uppercase writer, wrapped around a file writer, wrapped around the name of a file, so file 6.txt, and oh, I said filter writer instead of file writer. Then .use, so the use will take care of the closing for us. And then I can say it.write. This is a test, another line, and some uppercase text. And let's see what happens when I run this. So let's reload from disk. Take a look at file 6 and notice everything is in uppercase. Pretty cool. So we've encapsulated the concept of how to transform our text inside this writer for this wrapper here. Okay, and let's take a look at a couple ones that come for free. We're in this one, right? Yeah, there we go. So that's our uppercase thing there. Let's see, what was this? Oh, so a slightly different way to write the same thing that we just did here. Come in here and say file 7. And instead of explicitly wrapping a file writer around there, I could actually, if I had a file object to start with, I could say, give me a writer for it. Boom. Same kind of thing, that'll work just fine. And I'll say, let's just change the text here, hello there. There we go. So we have our nice little Star Wars conversation, and that should write out into file 7 that uppercase text. Now there's also some other decorators and adapters we can use. One adapter is called data output stream. And what data output stream lets you do is write out numbers and be able to read those numbers back in with a data input stream. I should say numbers and booleans and things like that. So we're going to start with our data output stream. I'm going to say file output stream because we're creating binary going out. And I will say file 8.bin. We'll use this. That is going to give us a data output stream that we can work on. And inside there, let's do a data output stream dot write 42 and maybe a write double 3.14159, and that's as far as I'm going to go. Happy Pi Day, everybody. And we'll do a string. Something kind of like that. So it's going to write out the UTF encoding of that string to the file. So let's take a look at what that looks like. Well, no need to take a look at it. It's just going to be gobbledygook, right? Let's create the complete mirror of that with a data input stream and a file input stream on that same file. So we're just going to read that file in. Let's rename this guy to data input stream. And here I'm going to say read int, read double, and read UTF. And then I'll just print these guys out just to make sure that everything came out just fine. And somebody's not happy there. Did he seriously not like pi? So write double, write UTF, read int, read double, read UTF. Where is he choking? On that read UTF. Something subtle is happening here. These don't look right. Oh, I didn't say write int. So what I did, by saying write like that, it's writing a character. So it's taking that 42 as an encoding of a character, and then I'm trying to read the 4 bytes for the int back there. Not good. If I change that to an int, we should be in good shape. Make sure you map these. If you're writing binary and reading binary like this, make sure you map them correctly. Otherwise, you can get some issues. And there we go. That worked out just fine there. Okay. Now, one of the ones that's going to be super common that you're going to use is something called a buffered reader. And buffered reader can make a huge difference in performance. What buffered reader does is, as it's reading, it reads a chunk from the disk, or reads a chunk from, whatever the reader is passed into him, which, because the way that disks are set up, they're set up for chunked input and output, it can be super, super efficient. This also works if you're reading and writing over a network connection, where the network connection, you can set up a reader or a writer, wrap a buffered reader around it, or alternatively, use an input stream and a buffered input stream. And what that'll do is when it's sending stuff across the network and getting stuff, it'll have more data inside of a packet. If you just use an input stream reader on a network connection or an input stream writer on a network connection, you're setting yourself up to write out 1 byte at a time for an entire packet. When I was teaching a class down in Atlanta, one of the students asked me, they said, hey, we're doing this network stuff and it's crazy slow. And I said, are you using a buffered input stream or a buffered writer to write it? And they're like, what? And I said, showed them how to use a buffered writer on it. And they came back and they said the performance was like 20 times the performance it was before, or something crazy like that. It's super, super important for network connections to make sure you're buffering your input and output. Otherwise, you are sending packets across with a single character in them, and that is just deadly. Okay, so this one here, buffer reader, taking a file reader of file 7.txt. We will use him, and I'll say it's a buffered reader. And the thing that's nice with buffered readers, you can also read full lines from that text. And so he'll take care of looking to see where the new line character is, and you don't have to worry about that yourself. So I can come in here and say while true, just to do this sucker forever, I'm going to say val line equals br.readline. And if there is not a line, if we're out of text, it'll return a null. So I can just throw a break right there. And then I can do a print line on him. And now we should see our nice little Star Wars conversation showing up there one line at a time. Now keep in mind, when you get this line, it will no longer have the new line character attached to it. But what readline will do is he'll take a look to see whichever new line is there. So it could be a carriage return, could be a line feed, or it could be a carriage return line feed combination. He'll take care of that for you. You don't have to worry about messing with it. Because unfortunately, different platforms have different ways of representing it. Linux platforms and the Mac have well, I shouldn't say the Mac. Linux platforms, I think the Macs do as well, have new lines as the line character. Macs used to use carriage return by itself. Windows uses a character return line feed combination. So getting that right can be a little tricky sometimes. This takes care of it for you. Okay, so any questions on any of that? Okay, well, that is all I had for tonight. I like to leave, have this lecture be a little bit shorter just to make sure we had room for the exam. Any other questions on the exam? Okay, awesome. Well, I will post the assignment soon and have yourselves a great week.